Welcome everyone. In this episode, we are going to work on NPCs. And I have a little plan for exactly what we're going to do. So we have our starter town, and it needs a little bit more sprucing up. So if you can remember from last time, we already have a little bit of sprucing. You see this thing? Those are animated. Wow. Such a spruced up place. So we already have some movement on the screen, but it's still very much dead. I want to have multiple classifications of NPCs. This is the most boring one, the one that's just standing there, no scripting, just walking around, fixed dialogue, nothing too fancy for now. And it's going to bleed into the next thing, which is going to, of course, be a chat system, some dialogue system. But for now, just NPCs wandering around, looking around, and they're going to be avoiding the doors and tight spaces. So at the present tense, doors don't exist yet. They're just tiles you can enter without any trigger, no special effects related to them. But what we don't want to have is NPCs standing over here. Or what we also don't want to have is have NPCs standing on this tile, for example. Now I would like to see them move through here, otherwise they're gonna just avoid this area in general. Also, I don't want them to stand here while the player is here, and of course this is already going to be avoided because I don't want them to be standing in front of doors anyway. So there's a few constraints, and then I want to give them a rectangle or some radius in which they're allowed to freely move, and they can choose themselves how they want to move, and it's just going to be a little random number generator dictating how all of these things go. So wandering an area, looking around to avoid doors and tight spaces. What I want to do is on a tile, I want to check the corner tiles. So for example, if I'm standing over here, I'll check this tile and that tile. They're both clear, so I'm okay to stand here. But if I look at this one and that one, this one's occupied, this one's free. So okay, that doesn't mean anything. But if both these tiles are occupied, that means that this tile is now illegal for me to stand on. And I will avoid getting onto this tile. The other thing, and I think that rule is going to capture most of the cases where an NPC would block the player. The other thing I want to do is not stopping in the middle of a path. And that is more engineered towards this segment right here, because I don't want you to stand still here and block anything. So another rule is if you have if you look again in the neighboring tiles, but this time we're going to go scan in a line above you. If one or two tiles are matching, and in the line below you, if one or two tiles are colliding, then it is a tile you can enter, but it's not a tile you're allowed to stop in. And hopefully what it's going to do is the player's NPCs are going to navigate here, they're going to look around, and if they decide to move up, they will do a 1, can't stop, 2, can't stop, and now direction doesn't matter, boom, they'll end up here. So that's the basic of the behaviors I'm going to go for. I think those two rules are going to go very far in getting NPCs working the way I want them to work. So the plan for today is we're going to classify the tiles based on rules number 1 and 2. We're going to spawn an NPC. The NPC is going to have certain movement states for looking around and committing themselves to small movements. So what I'm thinking right now is they can move 1, 2, or 3 tiles. So they would just, be in place, doing a thing. And then they would get the urge to say, I'm going to move forward for 1 or 2 or 3 tiles. So I added that. Maybe they'll do a little that. They can do a that. Maybe a little that. Just a little bit. They're going to prioritize tiles they're facing and then randomly choose left or right. And if nothing works, they're going to go backwards. And the last thing to work on today is going to be NPCs colliding with each other. And maybe at the end we'll have a little demo where we spawn a bunch of NPCs, throw them in the room, and see what happens to them, see how they interact. I think that's going to be a nice full day. I'm curious how far we're going to make it today. So without further ado, let's get started. We have a little debug renderer that we can use, and I'm first going to hook that in and do the tile classification based on the tiles around the entity. And once we have that going, we'll get the classification in. I'm going to extend this later if it's an NPC. So for that reason, I mean, it's test code anyway. So here in tick entity, we don't have, I'm messing up. We don't have a device. It's just pure ticking. Oh, I do like that split. Render entity, that's where we have a device. All right, that's good. All right. So now that we're here, we have a render offset. Oh, and a render coordinate. Can we do a coordinate? Yeah, that's a tall chord. Let's see how that looks like. If it's horribly offset. Oh, this is perfect. Yeah. This is the one we want. So let's start with the classifications. It's a lot. Okay. That's the grid we're going to inspect. Let's get cracking. So we're going to just first write the code in here. And see what... Oh, it's... Either way, it's messy. How do we know if it's legal to move somewhere? We gotta move direction. We gotta... Yeah, exactly. Here in move entity, we have a state overworld. We don't have it in render entity. There's just no perfect place. Let's just be messy. Let's just be messy. It's here. It's to do. Gonna remove it. Ba-ba-da, ba-ba-ba. Yoink. Cool, there's already debugs to do. We already overworld, so what was the function we checked in the handler? Overworld get tile attributes. There we go. Oh, and here we don't have an entity. If for player, we do have an entity. From inst to tile chord. Oh, okay. Really, this is surprising. So how did I normally make a tile chord? Now this part is a bit messy because we have the enter and exit flags. There's not a single number describing a thing as having collision. This is what the collision looks like. See, let's go somewhere familiar. Yeah, and the collision looks a little bit more complicated in the case, for example, here with having the cave entrance, because we don't want you to be able to walk through the cave entrance. Well, eventually it's not going to be a thing, because you're just going to go enter the cave, but still, if we will run any pathfinding, any analysis on this map, it's nice to know that we already banned upwards movement. So collision is not always that clear of an answer. It depends on what angle, what direction you're coming from. So we got the same here. Now what I do want to know, okay, so up is always first, up, right, down, left. So we're going clockwise. So I'm just going to assume that the enter up direction is what we're going to always listen to. Oh, so it's a state overworld tile attributes. So we start with green, and if the exit flags for up is 0, then it's red. This is not good if the first bit is set. My bad. There's nothing prohibiting you from exiting. Oh. Do have to use the color. There's nothing prohibiting you from leaving a tile if it's blocked. So this looks good. You have like the 4 green pixels in this tile and the red pixels where you're not allowed. I am curious what the cave entrance looks like. Cave entrance is green. Okay. See here, this is because the enter direction is invalid. But cool. This is all we need for classification. So let's wrap this in a lambda where be a beautiful one-liner. Return the thing with the enter flags up equals 1. Okay, we'll change this to... So there's 3 states we can have: forbidden, no stopping, and clear. So just for now, let's do the easy part, where we just set it to red. It works exactly the same. Now we can ask ourselves the question, which criteria are we not meeting? So the first one is easy. Let's do the 4 lookups. All right, so 0 is fine. One is no stopping, 2 is blocked. For this, we're gonna do top at 0, clockwise around. This -1, where's that coming from? Get rid of it. This is the base chord, and we still have to then nudge it. Do we have any tile chord math functions? That's a weird one. Yeah, let's just use it because it's cool. Chord. We move up. Yeah, this is a bit silly code. We go right, we go down, down again, go left, left. No. Oh, you're right. Who am I to doubt? Copilot. Up, up. Cool, that's it. So if let's check the right faces first. Oh, let's check them all at the same time. So if top right and bottom right, or bottom right, bottom left, or bottom left, or top left, top right, then we go classify as 1. And else it can still be second classification, and this one's harder to detect because now we want to see in all the directions, oh sorry, in the horizontal and the vertical directions, if there's a specific tile count. So I'm going to do a top count, which is from left to right 7 plus 0 plus 1. I don't even know for sure if this is legal C++. The right count is 1, 2, 3. Bottom count 3, 4, 5, 5, 6, 7. All right. If top count all right. What a mess. Oh, the colors are wrong, that's for sure. Oh, yeah, the last one, I wanted them to be red. All right, so this one's green, which is, oh, that's not what I expected. Yeah, if it is a colliding tile, that kind of simplifies the question. if core dot if we have collision on the core, then the classification is automatically 3, else that's when we do this. Yeah, this doesn't seem to work. So this one's red, which I can't Oh, I think what happens now is that we draw that's correct. Let's go diagnose for Alright, so now we just inspect a single pixel. This one shouldn't be a yellow. One should be easy to test because it should immediately go for a red. So the classification is 3. Classification 2, of course. That's why they just looked. I'm gonna save this file somewhere. Silly mistake. Yeah, red when it's supposed to be. Now what about in front of this one? Yeah, there's no stopping, which is correct because there's 2 on the left, 1 on the right. This one's supposed to be blocked because we got this one and that one. So first what we do go look at the bees. So this one's true and that one's true. So 7 and 1 are true. So the classification is 1, which is wrong. Should have been a classification 2. I'm just not numbering these correctly. So now it says this one's forbidden, and that's true because we got the corners. This one's allowed. These are all forbidden. This one's... Oh, I forgot that. Yeah, this one makes sense. Then this wall here, they're all forbidden too. Yeah, I forgot because I only want the corners. If the middle ones are not occupied, then it's fine. So if the middle one isn't, so 5 and B6, 7 and not B0. Now it's saying you should be able to pass it. Oh, I guess why? Because on this line and that line, it meets the criteria of 1. That's a hard one to say because who's to say you're not supposed to stop here? Because this is the main catch. I don't want you to be able to stop here, and that's correct. Not here, not here. Not allowed to stand there. This one's... Oh yeah, that one's fine. So I feel like there's an extra check to be done. Because right now, yeah, it's checking this one, this row, these three, and these three. What if one of them has to have 2 collisions? That's not the case here. Let's focus on this one. They're both next to each other. See, you think it out, and then you visualize it, and it turns out you're not done yet. Oh, at least we don't have any silly bugs anymore, so let's up it. I think what I want to do is just have the wall detection. So now we have 1-1, but they're also at the same offset. I'm gonna do the check, and let's see how it reflects where at least one of the middle ones must be occupied. So, and B0 or B4. And likewise for the horizontal case, it would be 2 and 6. Is that correct? 2 and 6, yeah. So you're not allowed to stand here. Oh, because on this row, yeah, sure. I mean, it's not ideal. It's way too simplistic of a test. Sure, if they're not standing in that corner, let them not stand in the corner. This is a weird one. They're not allowed to stand over here. That's only when they make that ledge jump. They're not supposed to stand still over there, sure. Yeah, these tiles are fine. Not supposed to cross this section. So, I'm happy with this classification. So let's yoink the whole thing. And now let's go looking for this entity type player. Let's add an NPC. In the entity handler here, you're an NPC, you would still adhere to the same movement rules. And lastly, here in the here we kind of do the update logic, and this is in a very messy way. Switch. This is probably gonna go to some brain class. All right. At least that gives us the classifying. It's done. Spawning. Let's do that. Creature entity handler player has a create player. This is weird, but it is what it is. Yeah, I'm not gonna dwell on it. Empty one is just gonna make an NPC right next to you. All right. In the render entity, if it's a player or an NPC, we're gonna, yeah, here's where we're gonna do some trickery. Because right now we're just saying, get the OEM 0123. We'll allocate them dynamic. Well, allocate. This is all fixed memory, so it's not really allocation. Oh, baby boy. You want to join? Hey, flying baby. You want to play with the keyboard, don't you? Hey, I know, keyboard, fancy lights. Fancy lights. And he's off. Every time he's done with his nap, Mom sends him in the room just to say hi. What a cutie pie. He just woke up from his nap. 4:20, good time. Long nap. He needs it. Anyway. Handler. What did I call it? Start rendering. I don't know how many OEMs I have. I think 64. Sprite count. So we'll just reset the OEM count, and here when we do the attributes, boom, and we're making sure, how many object attributes do we have? Oh, that's still a classic array. I guess we didn't refactor that yet, so let's do that now. Here we have, for example, we have a layer and then a fixed array of layers. And here we have an object attribute. And then we have a fixed array of object attribute. None of them object attributes. And the code should be identical because we have operator overloads. But the one thing it does have is bounce checks. But since this is here, we got a 64. I think we can get rid of that. Put the 64 straight in here. And wherever it breaks, it breaks. So here, when we're rendering, only render if we have 4 Cool. So if OEM plus 4 is larger, sometimes, where does it even get these numbers from? Well, we don't have the numbers here. We should do. Okay. Can we just return? Is there anything happening at the end? We have a... Yeah, it's all good. So now we should be rendering the entities correctly, although, yeah, that's another thing. Right now we have the character index, which is set to sprite index, and the sprite index is set by this static with an imgui callback to modify it. So at the moment, the character will just look like the player character. We'll get to it in a minute. So yeah, we're spawning the entity. We're not going to compile, but because of this, oh, size is UN32. All right, that makes sense. We have a self dot memory. Oh, we don't have. Ah, now this is a good question. Since we don't have this anymore, do we have? Can we just call? I doubt we can. Should be possible though, because right now we have n. Can we just get n? We have a data n. Probably some template stuff that is magic and can be done. Type uint8 function is not assignable, so we have the indice. Oh yeah, because the whole thing doesn't compile, so it just cascades. Is this legal? Maybe one day. I'll know how to fix it. For now, let's just go to the screen component. We'll have the OEM. OEM entries. All right. So we were supposed to have an extra player. Let's see what we can see with entity. We have a player and an NPC. What is our let's go. But what we should be doing here is add input. But that does mean, based on this, we have an entity with a coordinate and we're rendering it. Where it goes wrong is we're not rendering the entity. So what we should see now is if we go into look at our two entities, 140, 141. So correct coordinates. The render coordinates for the player character are set. For the Render entity, they're not set. Okay, so in tick entity maybe. If we're the player, oh, that's what we tick, so. What do we do in ticking? Oh, we do the movement. Okay. Good, correct stuff. So now we should see just the player. Yeah. So we can walk through him just like that. Oh, that's interesting. Yeah. See that in slow motion. No depth, there's no priority, there's no sorting. Awesome. I expect glitchy behavior. Do glitchy stuff, get glitchy results. There is a priority system, but if everything's 0, the result is undefined. Last thing, if I change the slider, yeah. Cool. So this file is clearly at risk of exploding. Also, this is update overworld. It should probably in its entirety move to a separate file. Anyway, we spawn an NPC. Done. Movement states. So we have the concept of, we have an entity, we don't have a lot of memory. Oh no, sorry, we don't use a lot of memory, so we're not going to worry about constraints. And everything's going to be pre-allocated, so there's no no runtime allocations. An entity is an entity. These things are going to determine everything. So I'm still tempted to say an entity, like to merge player and NPC entity into one, because they have the same, and I don't have to if player or entity or NPC do this, but then somewhere else I have to hold which one is the player. So let's keep it the way it is. I do need to add more state into this. So we have the traversal type. Traversal type being walk, swim, fly, ghost. We have a coordinate. We have a render coordinate, which may be different. An offset. Yeah, this offset is just a hacky bit, because when you jump over ledges, I want the camera to go in a straight line instead of jump up with you. Otherwise, the render coordinate would have had the same. Move direction. A state. Can I leverage the state? So we have idle, slow, fast, ledge. Yeah, I want a little bit more. So I'm okay with later throwing everything into a giant union, especially since one of the entities is going to be a pickup item that doesn't need most of these things. So, okay, so this is how it's going to move. We have tiles to move, which can be 0. When we're moving X number of tiles, we'll look at the state progress. When the state progress reaches a check, it will count down from X to 0. Once it hits 0, we either switch the direction we're facing, or we're gonna make a move. And if we're gonna make a move, we're gonna fill it in the tiles to move. How many tiles to move? Yeah, I think that's all the state we need. So let's go to NPC handler here, player dot, make sure that's 0. Yeah, so the state progress is going to be a bit of a weird variable. All right. So let's do the classification in one function. Nested lambdas, because why not? We already get a chord passed in. Difference is, instead of setting it to 2, we just return 2. Oh yeah, don't need this else. Make the code a little less horizontal. I'm gonna keep this debug drawing. Main reason for it later it's gonna be dynamic, maybe with other characters. Oh no, other characters are gonna be dealt with differently. Just turn it off for now. Cool. So we have our classify function. What would be nice if we can just add a direction. This one mutates. Let's do another one where all right. So the NPC will be when we're idling, we definitely want to move. So if we're idling, we may want to move, we may want to look around. I think what we're gonna do is just roll the dice. While we're idling, state progress. Oh, it's wrong. Let's just start with only the looking around. That's the easiest. If it's bigger than 0, decrement. else we want to look around. We're not going to do any classification, although it makes more sense to look around in directions that are more suitable. So what we want to do now is, just pick a direction. Here, move entity. It has to be a different direction. So it could just be the same one in that case. Oh, is that a thing we can do? Where we just supply a speed of 0, and that way we always just rotate and we don't do any of these checks. So here we say we want to go fast or we want to go slow, but all I really want to do... Do I even need to do this? Any shadow state, next move direction. Right. We don't have a rend, so let's hope it's fine. Yeah, we need our own random number generator. So that's fine. Now we just rotate in place. We don't care about classification just yet. Let's see what happens. Facing right. Just right. Only right. Always right. Okay, something in the tick is fighting the value. So while it's less than 32, we'll just add more memory. Who cares? Handler NPC. Right. Problem solved. Scratch that. If we have a delay, then we wait. Else we do. Then we set the delay. No more fighting. Didn't know full screen was on. Oh, okay. Yeah. Can you face any other directions? Thank you. Do a little up. Perfect. All right, so we can look around. Let's make a choice if we're gonna move or not. Also, when we're moving, right before we move, we pick a direction. Maybe we should already pick the direction here. It will prefer the front, but statistically it will be likely that it can go backwards, so it's fine. Entity dot I wouldn't say that, but at least we want to go to the left plus a chance to go forward or to the right. And then it's still possible when it's choosing a direction. So it will do a 90-degree turn or go straight. But it's also very much possible that after it makes a decision, then it's like, all right, I made a left-hand turn, but the one in front of me is not a good candidate, so I'm going to go left. So there's a chance of a 180, which is fine. So we're gonna, we don't even know if we're gonna go slow yet. We're gonna figure out. Does this immediately do the rotation? Yeah, here, if the state progress is less than 8, it's just going to return because all we're going to do is the rotation part. So, yeah, okay. Messy. Entity.state progress equals 8. Don't need to tell. Because doing the move is going to do the... going to push us in the right way. So we need to figure out what way to go. What happens to move entity? Does it... Yeah, okay, it takes the overworld, so it may still have any kind of collisions. It's still going to do the enter-exit flag check. But that's okay. We're just interested in a in the qualification. Sorry, the classification. So the classification is gonna now move into here. Ooh, let's risk it. Format document. Savage. Oh, by the way, I've done no... The wrapping of the directions will be done at the end. So these are our candidates. Forwards. Let's be verbose about this because we may have to wrap them around. Yeah, there's still... Yeah, here. Oh, let's do the wrapping right now. Do we have a... We have a max. Cool. Cool, and now if I'll randomly swap 1 and 2 with each other. Pilot's on fire. And now the first option I shall take. So this is to get the movement started. Oh, I already have I. Let's fix that. So if we take the entity coordinate, add the candidate, so tile chord, and then we'll run an L classify on the candidate tile. So if the classification, if it's blocked, then we continue. Else, this is the one. What's the speed? Speed is 0. Then pass it overworld. Either way, even if it fails, and it can fail because we may walk into another entity or for whatever reason NPC delay will be set already, just in case. Let's just see how it behaves. Alright, so now we want to... Now we gave the instruction. Let's go back here, because now if we're walking, it's all good. Yeah, so we're just doing the waiting part. We should also handle if we're walking. So if we're moving and we get to be idle, I need to classify elsewhere again. Oh. So here, if we're allowed to, if we're not allowed to stop, we're going to keep walking, and we're not going to decrement tiles. So, yeah, let's start with that. Let's do this in case of the edge case where we get parked in front of a door. Although that would mean, I mean, if we're parked in front of a door for some reason, that would just mean we may walk into the door. Let's just assume this never gets to be 2. Right? If it's more, cool. If oh, one thing is we don't do this logic. Let's move it here. You know what? I don't think we need to do the rotation because I'll do another swap. And that should do all the rotation, which direction we're going. So we're swapping 1 with 2, and there's also a chance we do 1 and 3. No, let's just do 0 and 3. So this makes sure we're 50-50, we're going straight. And else it's a 1/4% left, 1/4% right. No, otherwise it's, yeah, quarter left, quarter right. And reverse is the final callback, fallback. So that works, I think. We don't care about delay. Delay has been set to be something. Oof. Oh yeah, 1 tile. You walk multiple tiles. Walk around, look around, look around. Yeah, good. Think, buddy. What are you gonna do? Ooh, 2 tiles. I want to see him do a corner. Yeah, that was a corner. That was a corner. Awesome. Awesome. So he's looking around. Done. Small movements. Done. It's not colliding with anything yet. Let's increase the... Shall we increase it? Yeah, because the chances are that it's just going to face the exact same direction. And that's quite uneventful. So we're just gonna... Just gonna shorten the look around time. Beautiful. It's quite energetic. Right? Yeah. I want to play around with the number of tiles. So here, it's 1 plus... Boom. Yeah. Let him race. Sometimes there's some weird motions, yeah. It's like it gets to a tile, and just like how I'm allowed to stand still on a tile, it doesn't immediately go. I think it's this messy thing right here on the second pass. So if we're doing movement, or is this already? Yeah, we may want to... More messiness. Entity, movement direction. Going. Oh, yeah. Yes, plants. Look at her go. Not touching the doors. Beautiful. Beautiful little guy. So fast. So fast. Ooh, speaking of fast. Ooh, lights are off. Boom. Didn't even realize. There he goes. There he goes. Oh, so fast. Oh, wait. Is that a bug? Did I see a bug? Mm-hmm. Did I see the entity mess up when it gets to the top of the screen? Oh, yes. Oh, how poor. Cool. So what are we looking at with the OEM? 0 is good. 1, 2, 3, 4. Y is 85. Are these correct? These don't look correct. I think I'm drawing them in reverse order. So we got the player is at 0. Sorry, the NPC is at 0. So we got 64x, 5y. Yeah. I think it's just a simple bug in the here in the OEM indices. We sort them to go over. We fill them in the right scan line. If the Y is bigger than 256, we continue. If the Y is bigger than screen height, we break. If the scan line, oh, if we have more in the scan line. Yeah, this is the weird part, because the Y is 5 and we subtract 8 from it. This Y is a huge value. Because the problem we have is that if we take our virtual screen, we want to be able to have a sprite drawn like this. And in this case, what you should say is Y is 1, which makes sure that 1 pixel overlaps. So with a Y of 5, what does that mean? That this underflows. And of course this continues gonna get it. I think, oh, does it need to be? Oh, it's this break. Is it this break? What's the I? I is already at 1. That's weird. Okay. Now I know more what's going on. So, oh, and the next sprite is 13 minus 8. That's where the 5 came from. This is a weird debug session. This is part of game dev. I'm showing game dev as how it is, and a lot of it is just there's mental state and it doesn't translate well to screen. And that's just unfortunate. All right, let's do it again from scratch. 1000% Jamsocks. Yeah, indeed, 1000%. I still hope you like what you're seeing, though. Anyway, where's the simple silly bug? So oh, it's the whole thing. If we underflow, we don't reach this part. Okay, okay. Or why? Did that fix it? That was it. Whew. All right, so those kind of interruptions make you lose the train of thought. So we have a guy. He's happily walking. He's walking fast. He's a fast boy. Curious. Did I fix the speed? I think what I want for entities is not just a slow, a very slow. One day. It's getting close to dinner time, so I should consider wrapping up soon. But we still have one task, NPCs colliding with each other. And this one is gonna be a little bit more work, where we have to go to our entity, here to our move entity, and we have to iterate over all the entities that we have. The way I was thinking of doing this is having a class where you can say, oh, let me further explain the problem. We got our grid. You're moving from this cell to this cell, and if you're moving at, for example, a very slow pace, I don't want someone else to immediately enter this and start clipping with you. So while you're moving, it's going to be maybe at this point that this cell now becomes available. But the moment you start moving in that direction, this cell is now off limits for other entities. So some sort of registering the occupancy of a cell, some kind of system. So that's gonna be in the GM overworld. This is a weird one. Is it being used? No. Okay. Let me check my set implementation. Do I actually have a remove? I do have a remove. Fancy stuff. So whenever I create a entity, I would need to know the end of the day, where did I even add the thing? So here, what we want is have you on the side. Yes, I know there's plenty of redundancy here. Oh, my bad. Of course, it won't link, but all right. So the set does require some functions in order to work. Let's look at the cooker, how that happens there. It needs a hash and an operator, equal operator. So let's add them to tile cord. For the hasher, what do I need a util hasher. All right, so I need to be able to hash, yeah, the UN32 hash. Not sure if it just already takes UN16s, but okay. So I do have common H, I have common types. I do not have container set. Awesome. Do I have any insights on if this is working? Don't know. Let's just do the most simple thing, and that is because I'm right now calling occupy tile. I'm just gonna check if those tiles that are there at spawn are valid to be walked on. Move entity. So here, when I'll do it at the end. So now I shouldn't be able to get to this tile on my right and the original tile that I'm currently standing on. Which is correct. So let's update it so whenever I move, entity tick. Let's go to the tick. Oh yeah, right away. I mean, ledge jumps are gonna use a little bit more, are gonna need a little bit more love because I'm not checking for collisions with the target tile. But for now, you know, one thing at a time. Have to wrap up for the day. The target tile. I'm going to claim it. As mine. Is it because overworld is const? It is. Bad. So, and now what I want to do is the moment I go over, so in tick, movement default, that's where I fully left the tile, and the entity coordinate is still the old one. So let's go for, oh. Give me an overworld. Tick entity doesn't have an overworld. I do need my mutable overworld. So I can pass it in there. Boom. Compiler, tell me where. Tape doesn't, yeah. Occupy tile. Occupy, oh. Occupy, yeah. That helps. Yeah. Chase you. Oh, this is good. Well, there's only one logical thing to do next. That is to have more characters. Creature. Oh yes, this is it. I did the same thing that you can see on traditional hardware. There's a sprite limit, an OEM limit. That's clearly an effect here too. Oh, I'm very happy with that. Let's go. Nerds. Let's go, Nerd Squad. Awesome. Awesome. Yeah, if I do any more characters, it won't even... yeah. Exactly. If I do any more characters, I'm not even having the... It's not even going to try, because I'll reach the OEM limit. so it won't even render. So even though I'm allowed 64 entities, I gave myself 64 OEMs. And there are 4 OEMs per character. Awesome. Yeah, they definitely, their movement speed is on the high end for NPCs. They got no chill. Like for a player character, I expect to move this fast. And most of the time we'll probably be walking faster anyway because nobody has patience. But these are like especially the instant acceleration. It's like, let me go places. Anyway, I'm very happy about this. The only thing we didn't do is constrain them to a particular area. So if I crank up the speed, yeah, there's one guy already trying to escape. I can push him. Maybe convince him. No, going wrong way. There we go. No, you were doing so well. Go down. Ah! Well, there's one of them, of course, already made it out there. There we go. Yes, be free. Be free. Go to the beach. Go on an adventure together. Forced friendship. Awesome. Awesome, awesome. That's the last thing on the list. Done. Cool, cool, cool. Very happy. Very happy. You know, it's such an early stage for a project that it's hard to, you know, look at it and think this has any merit to it at all. So at least having something animated and then have something move around and have something bug-free, even though the code's a bit messy, it works and will get us places. So very happy. Thank you very much for tuning in. I really appreciate it. I feel like we got a handful of lurkers in chat. I don't think we got some quiet people, but I really appreciate having you in here. I wish you all a lovely evening. See you all next time.